Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get you started with Class 29 on logistic regression as applied to your project file. So scroll down to Class 29. There's not a markdown file here, which means that the assignment is in your outline file. So I will start RStudio. We will open up the markdown file. It's been a little while since we've worked in our assignment. I will first save the file with today's date, set the working directory to the current file's location, the source file's location, and I will knit the document. While that's knitting, I'm going to scroll down to the Class 29 assignment, and I see typo. And this is an assignment that is very much like the previous assignment, Class 28, where I gave you a data set to do a logistic regression. But this now is applied to your own data. So I think the model assignment from the last assignment we should use as a model here. So I will go open up that files Class 28. Okay, Class 28. I think I'm going to open up both of these, but we'll look at the HTML first. Okay, so I think this has, if I page down through this, it basically has all the data we need in terms of summarizing the data, which we don't necessarily need to do except for the deviance test, so yes, I guess we do. Plots of the data on the logit scale. So I think we might just copy all the code from the previous assignment as a starting point and then make sure that we follow all the parts of the rubric for the current assignment. I think that is a good way forward. So I'm going into the previous class's assignment, the RMD file, and I'm going to scroll down a bit past the data. Okay, we read the data set in, we don't need that part. We're also coding variables, we don't need that part. We're summarizing. So this is sort of the place where we'll get started. And I think that this won't be too difficult for this assignment in our outline file because it's the very last assignment. And there's if we copy a bunch of extra stuff, then it's just going to fill up the bottom of the document. It will be easy to get rid of the stuff that we don't need at the end. Okay, so there's the rubric, right? I'm going to scroll down a bit, and there's the end of the file. So I'm just going to press enter a bunch of times and paste in all the code from that previous assignment. Page back up. To our current assignment. There we go. All right, so I believe the markdown file finished, and we're ready to go review today's assignment, which I'm going to open in the browser. I'm going to make this larger and page down in the table of contents to that last assignment, logistic regression, and we'll review the rubric. All right, so first, recall that a logistic regression is a model where we have a binary response variable on the y-axis and a numeric variable on the horizontal x-axis. We have created a plot for logistic regression previously. In fact, if I page up to the very top and search for logistic, in Class 8, under plotting by variate, we did a plot here where we had a categorical binary response for the y and a numeric x. So if I click on that, and you do that too, I had nicotine dependence on the y-axis and total cigarettes smoked on the x. Now I've since commented out that piece of code because it was taking a long time to run. But there is a plot here, or at least a a relationship here that you've already looked at. The easiest thing for you to do, probably, if you're a bit happy with the choice you made previously, is to use that same relationship. Okay, so I've got total cigarettes smoked and nicotine dependence, and nicotine dependence here was coded as a 0,1 variable for the sake of plotting it. So I think I will make that same choice in the current assignment. All right. Oh, that's interesting. It zoomed out all by itself. Okay, so I jump back down to the bottom for the rubric. So select a binary response in continuous. Okay, there we go. Oops, a continuous. Well, a couple typos here. Continuous explanatory predictor variable. All right, first plot the data. So if you want to use the plot that you used before, great. You've already got that part done. If you want to sort of use the fancier code that I used in the assignment 28, you're welcome to do that as well. Summarize the proportion values for each value of the x variable. Now in our case, we may have many values of the x variable, and so a table like this is not necessarily super useful, but that's what the assignment is calling for, so please do that. Also calculate the empirical logits. We're going to use those in the next part where we plot p-hat values versus the x variable and plot the empirical logits versus the x variable. Okay, so we've got our p-hats and our empirical logits. Now our p-hats should follow the sigmoidal curve, that S-shaped curve, that lazy S. Whereas the empirical logits, right, on the logit scale, we're hoping basically follow a straight line. And if they do, then we can fit a roughly, basically like a simple linear regression on the logit scale. And that would be very handy. Next, you don't actually fit, just to correct myself for statisticians listening if that's the case, we don't actually fit a simple linear regression on the logit scale, of course. We fit a generalized linear model with a log link, and that is sort of, that creates a straight line relationship on the logit scale. Okay, describe the logit versus x plot, and is it linear? If not, we'll try to transform the x variable to improve the linearity, and describe the transformation if you choose to need one. Hopefully, for you, we'll get a straight line relationship on the first try. Otherwise, you can try trying like x squared, or the square root of x, or the log of x. We'll take a look at that in my example. We'll try a few scales and see how it improves. I can already tell this is going to be a longer video. Fit the generalized linear model and assess the deviance lack of fit to see whether the model fits the data. Calculate confidence bands around the model fit and those model predictions, and then plot both on the logit and p scales. All right, this is a code that we've got from the previous assignment, so that will not be very hard. And finally, interpret the sign of the slope. You know, as you increase x, does the probability increase or does it decrease? And test whether the slope is different from 0 on the logit scale. So on the logit scale, we have a slope parameter, and we have a p-value associated with that, and we can perform that hypothesis test. So this is a fairly big assignment, but it follows exactly assignment 28 in many respects. All right, let's get started. So first place we're going to do is plot the data. I'm going to get rid of this window, and we'll go over to our, you know what, let me go to my previous plot. I'm going to search for Logistic. Oops. And here's my Logistic plot. And I chose nicotine dependence and cigarettes smoked. Now, what I'm going to do is I'm going to steal from my previous, right, this is assignment 8 or something. If I page up for a moment. This was from class 8. Okay, so by plotting bivariate. If I'm paging back down, so I'm just going to take this first line of code because that has my variables in it, and I'm going to bring that over to RStudio, where one of the first things that I do, well, I've got summaries first, and then I've got a plot of the data. Now I just want to see this plot of the data, I think, has several aspects to it and may actually satisfy a couple of the elements in the rubric. Let me remind myself the elements of the rubric. Page down. So plot the data and then plot the p-values, the proportion values. So I think I can plot the data and those proportion values on the same axis. So I'm going to sort of combine steps 1, 2, and 3 all together, where I've got the data and the proportion values summarized, which get plotted, and then on a separate plot I've got the empirical logits, which are going to also be plotted. So I'm going to do a little bit of combination here. In order to plot the data with the p-values, I first need to summarize them. So I'm sort of going to skip to the second part first. Okay. And that's where this first piece of code comes from that we copied from the previous assignment. Summarize the observed probability of pregnancy. Now that's not right. The observed probability of success, I'll say, because that's a generic logistic regression term, for each unique value of x. Okay. And our variables, recall, are, we've got the data set NISARC sub, so that's going to go in here. And then our x variable is total cigarettes smoked. That is the thing that we're going to group by. And the thing we're summarizing are the nicotine dependence 0, 1 variables. Okay, so I'm going to cut that. We're going to sum the nicotine dependence. If those values are 0 and 1, where 0 is not nicotine dependent and 1 is nicotine dependent, and we add those up, that's the number of people who are nicotine dependent. And then we calculate the proportion of successes. So the proportion of successes for each unique value of x, and ungroup it. Now we probably want this to be a different variable name. In fact, because we copied this whole assignment from class 28 and all the data names there were .preg, we can do a search for .preg and replace that with something more related to our problem. So this pregnancy sum, I'm going to replace this with a search and replace. So I copied the .preg sum, I highlighted it, and I press Control-C for copy. Then I'm going to do Control-F. On Mac it's Command-F for find, and I'm going to search for that, and I'm going to replace it with, in our case, let's call it, how about DAT is fine. We've got nicotine dependent and total cigarettes smoked. Let's see, so we'll do nicotine dependent as the y variable, underscore, total cigarettes smoked. Maybe we'll just do, how about this, nic and cigs. I think that's maybe a little easier, underscore sum for summary. Okay, so those will be our summaries. This is already highlighted because that's what it found, so I'm going to replace that, and it's going to jump down to the next one. I'm going to replace this one, then we're going to replace it throughout. And there are a few other variables, whatever the x variable is, age at intercourse, that's now going to be our cigarette smoked, and our ever preg 01 is now going to be nicotine dependent 01. So we're going to end up replacing all those as well. And I'm going to go nice and slow, and I'm going to make sure that our line numbers stay down here at the very end and don't jump up to the beginning of our document and accidentally replace things that break. One way to easily keep track of that is I'm going to watch this ball down here in this bar and make sure that I'm only replacing stuff at the end of the document, which I know is new code. Okay, so I'm just going to sort of replace each of these, making sure I'm not replacing something I don't mean to. It is, you can see the box around the words sort of gives you, so you can sort of scan with your eyes what's coming next. Okay, it's still near the bottom, steering to the bottom. Great, no more occurrences. So let's scroll back up to the beginning of this section. Okay, I'm going to get rid of this stuff now. Other things that we can find and replace, I made a comment earlier, our X variable used to be age at intercourse. So I'm going to do a find on that. I highlighted it and pressed Command F. In fact, let me do that one more time. Okay, so I'm going to highlight this, and then I'm going to press Control F, and watch up here in the search bar, Control F, it puts the thing that is highlighted up in there. So that's good. That's the thing I'm searching for. I'm going to scroll up a little bit, look for my X variable, which is total cigarettes smoked. I'm going to copy that, Control C, and paste it here. Okay, and as long as age at int is a unique string, in fact, let's also do match case so that the capitalization is matched as well. And we do next. Okay, there's the first time that occurs, and we'll replace it, and walk through this carefully as well. Okay, so this is one way to make code that someone else has written your own by starting by copying and pasting each of the variables that you need in their code. Okay, I'm still paging up to the beginning of this, and there's at least one more variable, the everpreg01. Okay, so I'm going to highlight that and press Control F. That brought it up into the search window, and I'm going to replace that with, by scrolling up, the response variable now is nicotine dependence. I'm copying that and pasting it over here, and we will search for the next one. There's the first one actually, and we'll start replacing, and there was only 2 of those. Okay, I think we're now in a position where things are going to start working from the top. I'm going to page up a bit. Okay, so one thing to note here is the main thing I just did was go through the data, for the data set, and actually I didn't fix everything yet. For the data set and the variables, I found the old versions of those from the previous assignment, and I replaced those values, those variable names in our data set, with the one that we're using. Okay, find and replace was an easy way to do all of those replacements without making any keystroke mistakes. So that's another thing, right? Another way to approach this is to copy and paste one piece of code at a time and manually go and make the changes. That's okay too. I'm not necessarily advocating for one method over another. I'm showing you how I would do it. I would do all of it at once. That's a way of helping to guarantee that all the changes have been made, and you're less likely to miss some things. Now, the last thing that I do need to change is .preg. I saved that for last because by changing the .preg summary, which was originally what was here, with the new name, now I can go and change the .preg by itself with nisarc sub. Okay, so if I scroll down a little bit, I've got my .preg. I'm going to highlight that, Control F to put it in the search window, and I'm going to replace that with nisarc underscore sub. And I'll replace it here. And I'm going to go a bit slower now to make sure that there's no other versions of this data that I need to be concerned with. Okay, there are only a handful of them. Looks like there's another variable, this everpreg. That is the true-false variable from the previous assignment. I think it only appears in this piece of code. In fact, let me highlight that and press Control F and go to Next. Okay, it does appear in this commented version of the code. If I do Next again, it appears in this commented piece of plotting code, and that's it, just those two places. So this is not a piece of code that I need to change. Okay, so I'll page up. I think I've changed everything now. Go up to the beginning of the assignment, and now we'll start running one piece of code at a time, going from the top to the bottom. So I'm going to highlight this and press Control Enter. That submits it down to the console. I thought I had run this, but I had knitted it, but I did not run all the code from the top. Okay, that's a common mistake. I'm getting started on editing this code, but I haven't pressed this down arrow right here to run all the code from the top. So let me make sure that my environment is empty. It is. If it wasn't, or if I just want to be careful, I can click the broom, make sure that I've included hidden objects and say yes. That's going to start with a new environment. Another thing you can do to sort of start with a new environment, depending on your R setting, is in session you can do a new, restart R. Control Shift F10, that's what I press. That will restart R. It keeps us in the same directory, and in my case I don't ever save my environment in my global options. Right, so a good choice here. Oh, you know what? Restore.R data. I never want to do that. Oh, it doesn't matter because I never save it on exit. So I always sort of have a new environment. When I start R, my environment starts as empty. So that's what I want to have happen. So when I do that restart R, I know that empties my environment. Anyway, I'm starting with a new environment now. Let's run all the code from the top. This will take a couple minutes. So while this runs, let's sort of scroll down and predict what's going to happen. So I'm going to run this, and I'm going to get a table for each unique value of number of cigarettes smoked each month. I'll get a proportion of people who are nicotine dependent. And I'm expecting that as people smoke more and more cigarettes, that the proportion of people who are nicotine dependent should increase. Okay, so I'll have that table. Then I'm going to create this plot where I've got the X variable is the number of cigarettes smoked, and on the Y variable I've got the nicotine dependence value. Then I'm going to be plotting these p-hats. So from the summary data that we calculated in the table above, I'm going for the cigarettes smoked is X, and then the p-hats are going to be plotted. I think I can get started now that all the code has been run. I'm going to clear all my plots out. And is there anything else in here that looks like I need to make changes? Looks like just the labeling is what I need last. Okay, so we're in good shape. Let me scroll up to here. I'm also in the console going to press Control L, or you can click this broom to clear the console. So my console is starting empty, my plot window is starting empty. Anything that appears in those places came from the code that I'm going to run right now. Okay, so I'm going to highlight all this and press Control Enter, and no errors. So let's run the last line, which prints the table to the screen. Now I'm only getting the first 10 rows, and there's 95 more. So for me, there's 105 unique total cigarettes smoked. Now, one thing I notice here is that I have a ton, 25,000 people who have 0 cigarettes smoked. Now, this is a bit of an issue, right? So I'm looking at nicotine dependence and cigarettes smoked. I probably want to restrict my analysis only to people who smoke. Otherwise, this huge sample size is going to strongly influence the fit, and it's all about all these zeros are for non-smokers. So that's a bit of a problem for me. So I think what I should do is there's a few strategies here. The first strategy would be for these variables, cigarettes smoked and nicotine dependence, basically if someone never smoked cigarettes, we should just set the cigarette smoke to NA rather than 0. That will restrict attention about smoking only to people who smoke. In some ways, it's not that interesting to think about cigarette smoking for non-smokers. Same thing for nicotine dependence. Now, if I go up to the very beginning of this document and make those changes up there, it could affect previous analyses that we've done. So that's a danger at this point. Another thing that we could do is down here we could create either some new variables, or we could create a new data set. Now, I don't actually love any of these particular options, but I do think that the best thing to do is probably to recode, say, total cigarettes smoked, to restrict it only to people who are smokers. You know why I don't love that? There are probably previous analyses that use this variable, and I have included back then the non-smokers, and my interpretations include them, and so on. Here's a variable, monthly number of cigarettes. Okay, that's just calculating the variables. This is calculating some levels of smoking. This is a plot about age. Okay, so it looks like I've used this variable quite a bit. So I don't necessarily want to change it to remove the non-smokers. So here's another option. In the area where I create new variables, I think it's around here, coding 99s, maybe page down a little bit more. Creating new variables, okay, categorical to numeric. I want a numeric to numeric, there we go. How many of these do I have? Total cigarettes smoked, perfect. Okay, so anytime that total cigarettes smoked is 0, we want that to become an NA, and we want to create a new variable. So let's create a new variable that is that, but for smokers only. Okay, and so that is, I'm going to use this if-else statement. So if the total cigarettes smoked is equal to 0, okay, there's two ways to do this. Which way is more transparent? Either way is fine. If total cigarettes smoked is greater than 0, then let's use the total cigarettes smoked. Otherwise, total cigarettes smoked must have been 0. Therefore, replace that with an NA. So that basically removes all the non-smokers. Let's do that also with log 2 values. Looks like I probably ought to do that with log 2. I've already kicked out all the non-smokers. So if I need it, in fact, let me just make this super transparent. If I need the smokers version for log 2, then that's actually the same as the original log 2 variable, because I've already kicked out the non-smokers. Okay, so now I've got a log 2 version for smokers. Sorry, I was pressing tab. There we go. If I need it. Okay, so that's for smokers. Let's do the same thing for, or let's at least check it for nicotine dependence. Let's do a summary of NISARC sub for nicotine dependence 01. It's not quite what I wanted. because I also want to count the NAs. Let's see that. Table's not going to be 0 and 1. Let's see, those add up to about 43,000. That's all of the people. So all the non-smokers here are these zeros. So let's create a new variable also for the nicotine-dependent 0-1 group. Let's see, that may not even be important. What I was going to do is if you're a non-smoker, set nicotine dependence to NA. I don't need to do that for the logistic regression, and here's why. If I've got an X variable, or if one of the two variables has an NA for non-smokers, then I can't include the observation in the analysis. So I only need the non-smokers to be represented with an NA in at least one of the two variables. Anyway, I got the variable I need. Here it is. I'm going to now jump down to the bottom. Scroll up to the top of this assignment. Okay, and wherever I see total cigarettes smoked, I'm going to replace that with the smokers version so that I've removed all the non-smokers. So I'm going to replace it. Now I'm going to be very careful not to do all because I don't want it to wrap around. I've got wrap select here, wrap around to the beginning and change this for all the previous analyses in this document. Okay. So go as slow as you need to be careful about this if you're doing something similar. Okay, notice it's jumped up to the top now. I've lifted my hand from the keyboard, and I will say also, what the heck, I add this to my code book, makes sense. Okay, so now, this is for smokers only. Basically removed or replaced zeros with NAs. Okay, so that I've documented what I've done there. All right, let's jump down near the bottom again. I'll just search for the smokers variable. All right, so now I'm back down near the bottom. And let's now, I have to do one more thing. I have to run the code that creates these variables. Okay, so I will run this code. And let's get a summary also of the smokers. Okay, and we'll compare what we've done. So check this out. For cigarettes smoked, which includes non-smokers, the median is equal to 0. When we only include smokers, the median now is 360. And look at the minimum. The minimum is 1 cigarette. Okay? And that's what we wanted. So we've definitely removed all the non-smokers. Look at all the NAs now. Great. We've done what we wanted. All right, so I'm back down near the bottom now for our assignment. Let's rerun this table. And now, in our table, we don't have any number of total cigarettes smoked equal to 0. If you want this table to print out all the values, I'll show you how to do that. Notice it truncates it at 94. If you've got a long table, you can take your table and go to print and set n equals to infinity. So then it's going to print how many rows? N equals infinity. It's going to print all the rows. So I'm going to clear the console and press enter, and there are some NAs here at the bottom. Those will not be part of the analysis. Okay, the thing that I want to scroll through and just get a sense of is the p hat column. So here's p hat. It's the successes over totals. Now keep in mind that the totals are going to be highly variable. Check this one out. For the people who smoke 7 cigarettes a month, there's only 3 of those, and none of them are nicotine dependent. So the ratio, 0/3, is 0. So these are noisy measurements as we go, but I just want to take a look at the p-hat. The p-hat sort of starts at around 0.04 or so. Of course, there's a couple large values, but we're just going to get sort of a sense of, do those numbers roughly increase? As I scroll up, we're getting sort of 0.1, 0.2. We'll keep scrolling up. 0.2, 0.3. Okay. Keep scrolling up. Here's a 0.4, 0.3, 0.4. Keep scrolling up. Here's a 0.6, 0.3. Of course, these are very small sample sizes. It's probably better just to look at the ones with larger sample sizes like this. So 0.35, 0.29. Anyway, so it's generally, it sort of looks like there's a bit of an increase. As the number of cigarettes increase, larger proportions of people are nicotine dependent. So it looks like my hypothesis may work out here. All right, so let's look at the plot of the data. And I think because I've done all the find and replace, this piece of code will probably work just like it is. It's just that the labeling may be incorrect. So let's run this and take a look. Whoa! Well, that smooth curve isn't beautiful. Let me zoom in on this plot, and we'll discuss it briefly. So we've got zeros in the green dots. We've got zeros and ones, and along the horizontal. Okay, I need to relabel my axes. This is the number of cigarettes smoked, and this is the probability of being nicotine dependent. You know what? There's so much annotation that isn't quite right. I think I want to improve this plot a bit before I start to try to interpret it. In particular, I can remove some of the custom stuff that I did. So in terms of the axes, the y scale, scale y continuous and scale x continuous is really more about like you know, the y is okay because that's about a probability from 0 to 1, but scaling the x isn't great in this case, and it won't be good necessarily for your case either, because we don't really know the range. So let's just take the automatic settings for the x variable. Let's also remove some of these captions or change it to what they are. So proportion of nicotine dependence by total cigarettes smoked. And I'll put a subtitle in here of just, this is observed data, smokers only. Okay, the x variable is total cigarettes smoked, and the y variable is nicotine dependence as a 0-1 variable, and observed probability of nicotine dependence. Okay, green indicator points of nicotine dependence 1 or not 0. Black observed proportions of nicotine dependence. Okay, so with those corrections, I think this plot is going to be much easier to look at. Okay, much better. All right, so on the horizontal axis, I've got total cigarettes smoked. On the vertical axis, I've got nicotine dependence 0-1. The green dots indicate people with nicotine dependence as a 1 or not as a 0. So those are these sets of green points. The green points are really clustered close to 0 for the people who are not nicotine dependent, which is the 0 on the y-axis. whereas the people who are nicotine dependent, the ones, are sort of, these values are more spread out. We have the black points are the observed proportions. So that's the proportion of successes, or excuse me, the number of successes divided by the total for each total number of cigarettes smoked. And there's a lot of variability here, and that's because a lot of these values have very small sample sizes. The very tiny dots represent very small groups. Could be 1 to, say, 10 observations. There's a couple larger points, and that's like people who smoke, you know, a pack a day, or maybe like 5 cigarettes a day every day, things like that. And so we get a bit of an increase that comes up, and then it seems to trail downward. And but I'm not going to sort of trust this red line too much at this point. We do have this larger point right here, which is a bit low as well. So there's some evidence here that, you know, maybe it goes up and then comes back down, or I don't quite know what to think yet. I'm sort of expecting, I would expect this to be a lazy S. So it sort of increases a bit, and then flattens out. Sort of like it would be high up here and then come down a bit and then flatten out again. So I don't quite know what to make of this decrease. I'm not going to worry too much about it at this time. But the proportion of nicotine dependence by total cigarettes smoked, that looks okay. Observed data, smoking only. So all the annotations looks good. So if we go back to our rubric, we have plotted the data, we have summarized the p-hat values, and we've plotted the p-hat values with the x variable. So that's good. The next part is to calculate the empirical logits and to plot those. And that's the point where we're hoping that the empirical logits sort of follow a straight line relationship. All right, so let's scroll through the assignment. You know, the code from the previous assignment. Here's the logit scale. Good. If the points follow a straight line, then we can, you know, etc. Influenced. It looks like I made some typos in the last assignment. So here's the code where I add to our summaries the empirical logits, and then I plot those. So if you've done all of the find and replace, all the code should work. The main thing here is some of the labeling. Okay, logit of nicotine dependence by total cigarettes smoked. I'll fix that in a second. The y variable is the empirical logit of the probability of nicotine dependence. That's my y variable. Okay. I sort of over-labeled the plots from the previous assignment, so there's a lot of text to replace. Okay, the last thing I need to do is replace the text for the labels for the x variable. I'm going to be lazy. I'm going to page up a bit, and I'm going to copy total cigarettes smoked from that previous plot, because I hate typing things multiple times, by the age. Okay, so age is getting replaced with total cigarettes smoked. And I think I've gotten everything. The thing that's probably not going to work is these scale Y and scale X values. I'm going to comment those out because that sets the axes limits. All right, so let's run this. And I love it when things work the first time. That does not happen very often in my experience. All right, so we've got, now we have the empirical logits on the y-axis. Notice here's a 0, and it goes negative and positive. 0 right here, by the way, is a probability of 0.5. So if you needed a reference on the logit scale, that's 0.5. We've got total cigarettes smoked on the x-axis. All other labeling seems to be correct. Maybe the last thing I'll sort of change while I'm thinking of it is the subtitle, observed data for smokers only. And I didn't need to rerun this, but I am. All right, so the red curve is just a smooth line, and the blue line is an example of a straight line fit to this data, just as a reference to see do these black points sort of follow that straight line relationship? And in my case, I would say no. If I ignore sort of some of these people who are super high smokers and restrict my attention to sort of the 1,000 and below, this curve right here, which sort of starts steep and then shallows out, that suggests to me that if I were to, I should maybe take the logarithm of the total cigarettes smoked as the x variable. And because this type of shape should get straightened out with a log transformation. This is not the video for me to go through all the possible shapes and the transformations that could help with that. You see me or one of the other instructor helpers in office hours if you need some more help with that. But what I'm going to do now, because I'm unhappy with this straight line relationship, is what the assignment tells me to do is, right, so I've plotted this the empirical logits, and I want to describe that logit versus x plot, and it's not linear, so I'm considering a transformation to improve the linearity. And I've already, in a previous assignment, created those log2 variables, and that's some of the code that I just ran. So if I page up a bit to the beginning of this assignment, the x variable is this smokers variable, and recall I created this smokers log2 variable. Okay, so I'm just going to go through the code at the bottom and replace my smokers with smokers log2. Okay, so I'm going to jump back down there. Is there, let's see if there's a faster way to get down there. Okay, well, it's not exactly what I wanted, but scrolling around the bottom of the analysis, here we go. Okay, so wherever I see total cigarette smokers, I'm going to replace that with smokers log2. So I'm going to highlight that, copy it, do a Control F to search for it, and replace that with with my log2 version. And I'm going to be gentle here and make sure I'm only replacing the smokers, the total cigarettes smoked at the bottom of the assignment. Once it loops up to the top, I'm going to stop. Okay, so replace, replace, replace. Okay, I'm still near the bottom of the document. And aha, I just jumped up to the top. It was down here at the bottom the whole way until it jumped up. Now I'm near the top of the document. I'm done. I'm going to scroll down. Maybe I'll just do, I'll just scroll down like this and find the assignment again. Okay, I think this is the beginning. Okay, so I will acknowledge that this is a more challenging assignment just because there's a bit of jumping around and keeping track of where you are in the code for a fairly long document. So let's run this. I've got so all these proportions are going to be the same, but the only difference really is that the x variable now is on the log2 scale. Okay, so all those proportions will work. I'm going to plot the data. We can zoom in on this plot once it finishes. And now this should look substantially different because it will have changed the shape of the x-axis. Interesting. Okay, so it no longer, right, previously it raised, the curve rose steeply and then it sort of trailed off downward. Now it's sort of rising shallowly, and almost to a degree that, I don't know, this is starting to look like a bit of a lazy S, except for this right-hand side where it sort of just drops off. If this had sort of more plateaued and gotten flat, then it's a bit more like the lazy S that we're hoping for logistic regression. Let's scroll down a little bit to the next plot of the empirical logits, because that is the key plot. Empirical logits. Okay. I'll put this in your window. So, do these data seem to follow a straight line? This is quite a bit better. It starts to deviate right here when the x value is about a 10, right? So 2 to the 10th power is 1024. So once you start smoking more than 1,000 cigarettes per month, it seems that the model's not really going to work. But before then, up to 1,000 cigarettes a month, we're getting a pretty nice straight line relationship. There's only those people who smoke a lot, for whom this model may not work very well. You know, if this is a very natural situation. So the model that you fit may not apply for an entire range of possible values. This model we'll continue with the model that we're going to have, but this model is going to work well for people who smoke up to 1,000 cigarettes per month. If you smoke beyond that, the model that we fit probably won't fit very well. Okay, and you may need to investigate a second model. There is something called is it called piecewise regression? It's got like 2 or 3 other names, where you actually fit like a straight line relationship for part of the regression, and then you find a change point, and you fit a second line to the rest of the data, and that model figures out where that pivot point should be, and then it also estimates the slope and intercepts for each part of that regression line. So that you can imagine 2 straight lines here that sort of intersect at a certain point. So something like that might be a good choice for this model or for this data. But we're going to continue with the data and the analysis that we've got. So I think that this transformation has really improved the situation. So I'm pretty happy with this. The only thing that now I need to change in the titles and the axes is I need to put log2 scale. So I'm paging up a bit. Okay, so this is the first plot, proportionality by, I'll just say right at the front here, log2 total cigarettes smoked, log2 total cigarettes smoked, and then if I go down to the next plot, I'll put log2 in the labels as well. Oops, missed that one. And I'm not worrying too much about capitalization. Okay. Okay. Also, while I'm working through this, notice I'm not working too hard on answering each of these questions. I'm making sure that all the sort of code is working and that I've made my final decisions about transformations and things like that. Once I'm done writing most of the code, I'll go back and I'll do the interpretations. Okay, so we're basically done down through here. We've done all the plotting. I'm happy with the transformation that I've done, and the data now are pretty linear, at least for most of the range. And let's move forward with a logistic regression for this data. These next steps are not going to be as time consuming as this first. I'll hope maybe 2/3 of this video. All right, so then the next part is the simple linear regression model. I've got some equations in here. That's just fine. We'll just keep those hanging around. All right, so we're going to fit our model. We've got success and total were defined in the summary, and we've got the X variable here, the smoker's log 2 version of total cigarettes smoked. So this looks good. GLMPA maybe doesn't apply to us anymore. Maybe we won't want to relabel that. You can if you want. Let's do nicotine and cigarettes. Total cigarettes smoked. Oh, now I need to remember what I just did. So I want to do a find and replace of this. So I'm going to copy that, do a Control F. That brought it up here. And I'm going to replace that with a nicotine and cigarettes. So N_C. Now I'm going to be very gentle here in case I'm not going to have any GLMs in a previous part of this assignment. So I could probably do all, but I'm always very careful with this. So I'm going to replace all those instances since I know I'm down here at the bottom of the assignment. Replacing all these things, and no more occurrences. Great. So I'll scroll up to the first instance of this. Okay, and I'll run the generalized linear model. Okay, no errors. Now at this point, I want to know that this ran and I got something. So let's just print out that object. Okay, I just printed out the object that we created and said it fit a GLM. It's got the intercept and the slope, and it's got degrees of freedom and all that stuff. So, all right, so I've got an object that I know I can work with. All right, let's scroll down a little bit. I've got a deviant statistic. Okay, there's all this code here from, I'm just going to delete it. That really doesn't apply to this assignment. Deviance lack of fit. Okay, let's run this command here. Okay, what did we learn when we ran that code? I guess it's just these lower lines. Okay, I've printed out the deviance statistic, which is 310, which is quite large. We've got a chi-square distribution with 101 degrees of freedom. The p-value is 0. Just for curiosity, if we print that out to 3 significant digits, it's still 0. Okay, anyway. We have a very small p-value. We have fairly strong evidence here for that our model does not fit the data, that we have lack of fit. Okay, so we'll just report that and acknowledge this. What we would do in a real analysis at this point is we would stop with this model and we would try a different model. There are other good models to apply to this data. In particular, maybe a quadratic model which has sort of a downward shaping parabola could fit. So that would be a model that doesn't only have, if I hover, will it show the, okay, well, there's the model equation. So here I've got an intercept, a slope with x, but you could add plus beta 2 x squared, and that x squared would give you a parabola, and that parabola would give you sort of a downward shaped parabola, now downward shaped plot. Now I think a downward curve shaped plot. Now I don't think a parabola would fit this data very well. This does not look like a parabola to me. But there are alternative models that you could propose. For the sake of this assignment, what we will do instead is simply, we've done our best with the transformation. We have a result for the deviance lack of fit test, which says that our model doesn't fit the data. We will decide that, in fact, in my case, that model doesn't fit the data, but we will continue as though the model does to provide our interpretations and so on, because that's a good way to do an assignment like this. All right. So that's the GLM model and lack of fit test. Next part are the plots with the confidence bands and so on. So let's scroll down to the next part. All right, I think all this code should just work as long as you've got your updated GLM object in here. So we're going to create our predicted values with their standard errors. We're going to run this add some columns to our summary table that has on the logit scale and the p-values, or on the proportion scale, the predicted values and the lower and upper bounds of the confidence interval. Oh, let's see. Column fit logit must be of length 104 or 1 and not 103. So one of these rows, I think, has some NAs. This is not a disaster. And in fact, this probably will happen in your case too. I recall, all right, so let's make this a bit bigger. In our original table, I remember printing this out with all the rows and having this last row where we had an NA. Okay, we want to exclude this NA row from our data table, because what happens is we try to make predictions we're trying to predict p hat for all the values of our x variable. But if one of our x variables is equal to NA, it can't make the prediction. So in our original table, we want to drop, oh, that's weird. We want to drop any rows with an NA. That's pretty easy to do. Let's go up and fix that original table piece of code. It won't affect any of our other plots. Okay, so here's where we create our original summaries. Okay, so let's just run this code to take a look at this problem. There's our problem. Okay, so now the last thing to do is na.omit. Okay, so if I add that to our summarized table and run it, now I've got only 93 rows. That's good. And if I print it out, the last row no longer has an NA. And instead of 104 rows, I now have 103. So now none of my summaries have NAs. So I can go through all my code now. I'm quite confident that all this is going to run. I'm just going to run it because I want you to do this if you make a big change like this, to confirm that all your code still works. Okay, so I would be going through and making all my plots large and make sure that they look the same. I know that in this case that they will, but it's good practice. I'm still scrolling down. We're going to fit the model. I know that it doesn't affect the model fit because it doesn't include NAs in the fit. It shouldn't change the deviance statistic. And here is we run our predictions. I'll run this the same way as I did before. So here's all the predictions. That should have 103 rows. And so we have 10 plus an additional 93. So that's 103. That doesn't include the NAs. Now when we run this, and we try to merge all those data values together, it works just fine. So now our table has all the original columns that it had, but now it also has the fitted values, which comes from the GLM model. Okay, so this is great. We've got everything we need. Let's create our plot. And I think all this code is probably going to work just fine. Possibly not the scaling the x and the y variables, and not the labels. So, if this was me, I would just go ahead and click play, but I'm going to tidy up the plot first. The part that will work is all the model fitting part, right? this line that comes from the modeling. That's just going to naturally work. Looks like geom point size equals total. No, that's fine. All right, and so then we just need to update these titles. Logit of. Okay, so I'm going to page up and steal from my previous plots. So I copied the title from a previous plot, and I'm going to remove the old one, and then I'm just going to replace these variables. Nicotine dependence, that is the y variable, probability of nicotine dependence. X variable is total log 2 cigarettes smoked. Observed logit proportions of given log 2. Okay, so we got logit nicotine dependence of nicotine dependence given log 2 total cigarettes smoked. All right, the rest of this looks good. The main thing I did there was just change the labels. Let's take a look at our fitted model. This looks darn good for me, at least up to, a value of about 10, where we get these strange decreases in the probability of nicotine dependence for the people who smoke the most. Now, this very likely is an effect of how people are diagnosed with nicotine dependence, and whether these, right, there's a few things that could be happening here. Is one about how are people diagnosed with nicotine dependence. Second, these are people who are self-reporting the number of cigarettes they're smoking. It could be that these people are overestimating the cigarettes that they're smoking, and they actually belong a bit to the left over here, and maybe they actually fall in line. Probably there's issues of measurement. I don't believe that if you smoke more than 1,000 cigarettes per month, that your probability of being nicotine dependent decreases. I don't believe that. I believe that this increasing relationship probably holds. It may not be this particular relationship that we're looking at here, but generally speaking, I think that smoking more probably is more related to nicotine dependence. All right, so let's go back to the rubric. We've got confidence bands around the model fit and prediction, and I've plotted it on the logit scale. Now we need it on the probability scale. That should be the next bit of code. And here it is, the probability proportion scale. And almost everything should probably work because we've already done the find and replace. Because we're now on a probability scale, the scale y going from 0 to 1 is going to work just fine. It's just the scale x that is probably not working, and these labels need to be improved. So let me grab one of these lines that have both of my variable names in it, and I'm going to sort of put it here just for a placeholder. Now I've got nicotine dependence for all my x variables, for my y variable, proportion of nicotine dependence. One thing I'm liking about RStudio is that when I highlight this, it puts a box around the other instances. So I'm able to look ahead at where I need to do this replace. Indicator points of nicotine dependence, and then we've got log 2 cigarettes, total cigarettes smoked as my x variable, and that's going in place of age for my x variable, and I almost have them all, given age. Okay, I think I got them all. And now I'm going to remove that title that I copied down just for the sake of having the variable names here. Okay, let's scroll up and run this plot. There's a lot of lines here. Hope it works. All right, so here is my sigmoidal curve, my lazy S curve. Now this is the sort of the leftmost part of this curve because it's curving up, up, up. It's starting to flatten out and sort of curve down, which it would eventually do. But no one can smoke, more than, let's see, 2 to the 12th power would be 2 to the 10 is 1,000, so we've got 2,000, 4,000. No one can smoke more than 4,000 cigarettes a month, I guess. Wimps. So, okay, so that's sort of where our model ends. Now, we definitely start to get major lack of fit here beyond x equals 10. But for the most of this data, this looks pretty good. I'm generally pretty happy with what's happening here. One thing I'm not very happy with is the jitter. I think I've maybe have the jitter too jittery for the width. In fact, let's not jitter the width at all. I think it's really distorting those x values. Okay. I guess I don't know. We've got the black dots that indicate the sizes, but all right. I think this is okay. Let me go up and fix that other width up near the beginning. I think it's one of the first plots we made. Here it is. Or maybe make it very small, maybe like 0.5. 0.05. Okay, this looks a little better. You can see sort of the high density points without it. They're not overlapping horizontally now as much. Okay, I think this is a decent summary of this model. Now, the last thing that I would probably do if this was a publication is I might, sort of a baby publication, is I'd maybe stop at the value 10. So at 1,000 cigarettes, refit the model for data just going up from 0 up to 10 and see how the model fit is. And then say that we have severe lack of fit beyond that. And so our model only applies up to 1,000 cigarettes per month. And just to say that we did not model extreme smokers. All right, let me page down a little bit more. Oh, let's go back to the rubric. So we've got the confidence bands on the Logistic scale, and now we've just finished the proportion scale, and then to do some interpretations. So let's scroll down a little bit more. We have the secondary plot. I'm going to get rid of that alternative plot code and interpret a model prediction. So this is not something we're doing for this assignment because I can't give everyone a specific model prediction value. Okay, so I think that's those lines that I've highlighted. Okay, so you can keep the summary table below, basically gives the MLE. So let's look at the summary table. I put my cursor on that line and press Control Enter to submit it down here in the console. And we've got our intercept of -2.9, and we have our slope of 0.23. So our slope is positive, and so we want to interpret this as a positive value. That basically just means as the x variable increases, a positive value means that the y variable increases. So we have this positive slope, this increasing relationship, that the probability of nicotine dependence increases as the number of cigarettes smoked also increases. Okay, so that's the interpretation for that one for me. And then, what is the last part of the assignment? And then test whether the slope is different from 0. Okay, so going back to this table, this summary, this coefficients table, okay, I have this estimate of the slope for my x variable, and the p-value is basically 0. So I have strong evidence that this slope is not equal to 0, because this hypothesis test, the p-value for in this column, tests whether these parameters are equal to 0 or not. And here we have strong evidence. This z statistic is 23 standard errors away from 0. That's very far. Anything beyond 2 starts to get far, and we're at 23. So we have strong evidence here that this is a non-zero slope. And so we would reject the null of the slope equal to 0. Great. The last part of this video is just going to be me going through, because we've effectively answered all the parts of this assignment with the code. We just now need to put things where they belong in the rubric. Okay? So I'm paging up to the rubric. Here we are. Okay, class 29 on logistic regression. Oops, sorry about that. That was sloppy. Okay, on logistic regression, we have all these sections. It's probably pretty good to make each of these sections its own subsection in table of contents. So we are at a level 2 hierarchy for our table of contents. So let's make each of these parts of the rubric a level 3. So I'm going to delete the rubric part. We can leave logistic regression there, that's fine. And then for each of these stars, I'm going to replace it with a triple pound sign and get rid of the star. And put each part of the assignment where it belongs. In fact, one way to sort of do this is I'm going to highlight the spaces and the star, and I'm going to copy it. Let me try to do this a little bit easier way of following. So I'm going to highlight this. I'm going to do Control F to search for it, and I'm going to replace that with pound, 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 space, which is what I see that I needed to do right there. And then I'm going to slowly replace each of those and stop. It jumped up to the top of the assignment, and I do not want to do that globally. All right, so let's go back down to, I guess I can search for class 29 and start to put things where they belong in our assignment. Alternatively, you can move these headings down to where the code is. I will probably move my code up into these areas. So for plot the data, I'm going to say see below. For summarize the p hat values and the empirical logits, I'm going to put the code right up here. So now it's going to be a lot of scroll down, copy, scroll up, paste. So I'm going to scroll down to where I start to summarize things. Okay, and I'm not going to worry too much about these headings right now. I'm going to tidy that up on the next pass. Okay, so I'm going to copy calculating the table and probability proportion scale. That's the plot, isn't it? Let me go back up to the summarize the p hat values, also calculate the empirical logits, and then plot it. Okay, I think I can put the code for the p hat and the logits here together. So this first one is the p hat table. So I'm going to cut that, Control X or Command X, and I'm going to paste it in here. Okay, so that's the p hat stuff. Then the empirical logits. So I've got this plot I'm going to skip past the plot for a moment, and then I've got the logit scale. And this first piece of code here is the empirical logits. It adds one column, the empirical logit column, to my summary table. So I'm going to grab that and move it up with my table. Okay, I'll just put it right here, which it will compute before it prints out the table. Okay, so that will work without breaking anything. Then I've got my plots of both the p-hat values and the empirical logits. So I'm going to page down now and grab my two plots. Plot the data, I'll remove that. I put a fourth pound sign in front of probability proportion scale. There's my first plot. And then I've got my logit scale. I'm going to add a fourth pound sign there. And I'm going to keep all the description there, I guess, because it's sort of still relevant. And let's see, I've got this for the plot above something or other. So I'm going to keep that for a moment. Okay, copy all this stuff. Probability and the logit scale plots, page up, and paste it here. And then describe the logit versus X plot. Is it linear? So for the plot above on the logit scale, does it appear that straight line fits well? So that's the question I'm answering. And I said that the log 2 of total cigarettes smoked improved the linear relationship. However, let's see, a straight line describes the data well. From 0 to 10, but does not fit the data when x is greater than 10. Okay, so that's what I observed about the linear relationship. Then we fit the generalized linear model. So I'm going to page down again. Here's the regression model. If you want, you can keep the text here along with it. Doesn't hurt anything. We've got the model fit here, and we have the deviance statistic. Why don't we copy that code up as well, since we're gonna be doing that right away. So I cut all that code. There's the GLM and deviance statistic. Okay, good. And assess the deviance lack of fit. So now we need to say something about the conclusions. So we've fit the model. I'm just scrolling back up to the top of this part. Okay, so we fit the GLM model. Write the model out there, that's good. And then we fit the model right here. And then we've got our deviance lack of fit statistic. So I'm going to add a pound sign here to sort of, I've got 3 pound signs for this part of this rubric, and now I have 4 pound signs for the deviance lack of fit. All this code still holds just fine. You can, all the text, you can keep it like that if you want. And we're going to state the null and alternative hypothesis. So we'll say the model fits the data, and then model does not fit the data. We have we don't really have these 1 points anymore for this. That was from the previous assignment. For your preferred model, the deviance statistic is, so that's this value here, that deviance statistic. We can put that in here with 2 backticks and an R space and the value. And we can print this to 3 significant digits. Similarly, we have the degrees of freedom, but that's an integer, so we don't need our 3 significant digits. The df residual is that degrees of freedom, and the p-value to 3 significant digits is this p-value there. So I'm going to put that value there. Okay, and just to test one of these, if you highlight the code after the R space and press Control Enter, it will submit that down to the console and print that value. Okay. Okay, that's our statistic, and what's our conclusion? Because the p-value is less than 0.05, we reject the null hypothesis in favor of the alternative, concluding that the model does not fit the data. However, for this assignment, we will continue with, interpretation. Okay, so we calculate the confidence bands and plot that on both the logit and probability scales. So that's just the next 2 plots. I'm going to start to delete some of these spaces. Model visualization. We can keep some of that text. It's helpful description. I'm sort of thinking for you later on, if you're using this document as a reference, it's helpful to have some of these descriptions in here. So we create the predicted values, we calculate those confidence intervals and so on, and then we're going to plot it on the logit scale and on the probability scale. Okay, a lot of stuff there. And that relates to the plot, so I will cut that and move it up to the plotting area. And I didn't have you really discuss the plots. I'm pasting it in there, so there isn't really that much more to do after you put the plot in there. Sorry, I'm paging up and down for a second. Here we go. Calculate the confidence bands and plot it. So I'm just going to scroll down gently now. Logit scale, I'm going to put a 4th pound sign for logit scale. There's the plot. We don't need to make any of these comments, so I'm deleting that from the previous assignment. On the probability scale, I'm adding a 4th pound sign for the table of contents. And we're not interpreting that plot directly. And then finally, interpret the sign and perform the hypothesis test. So I'm just going to press delete. Oops. Bring that up. The summary tables give the MLEs and the regression parameters. Okay, complete the equation below. We don't need to do that. And interpreting the model coefficients is tricky. So here's 2 areas here of interpret the sign, and I didn't ask you about the intercept. I wanted you to do the hypothesis test. Okay, so we're pretty close. Interpret the sign of the slope. So we have, recall, in our summary, we have a positive slope. And so we want to interpret a positive slope. As the log 2 total cigarettes smoked increases, I'll just say as x, that variable, increases, the probability of success, I'll put success in quotes, of nicotine dependence increases. And I should say, because our slope is positive as x increases, probability of the y variable increases. Okay, that's good. The last part was the hypothesis test. Test whether the slope is different from 0. Okay, so I've already stated the alternative hypothesis here. I'm going to copy that and we'll put these hypotheses down here. So there's the alternative. We can make a copy of that and put a h0 and put an equals for 0. Okay, those are our alternatives, and we just need to do a full hypothesis test. So we want to grab this p-value right there. It's probably enough to just type this. I will show you because this video has gone on long enough, and if you're still with me, then you're in it for the end. So let's look at the summary, and notice I've got a comment here that you can grab the names of the summary object, and one of these should be the coefficients. There it is. So in the summary value, I've got a $sign coefficients, and that should give me the table, the coefficients table. Now we're looking at the second row and the 1, 2, 3, 4th column. Okay, so second row, 4th column, that's the p-value. Okay, so I'm going to grab that value and put it in the text. The p-value equals this value to 3 significant digits. Let's see what we get here. Okay, looks like that. Also, if you wrap this in $signs, it will typeset it using scientific notation, and it will look nice. Okay, so the p-value is that which is less than 0.05. Therefore, we reject the null hypothesis in favor of the alternative, concluding that the slope is different from 0. That's it. Phew, that was a monster assignment. I've pressed Control S for the first time in an hour and a half or something. Please save your document more often than I just did. And I'm knitting it. And if I didn't make any coding mistakes, then this should compile. We'll give it a quick scroll through, and make sure that things look nice. If not, I'll do a very quick tidy up and we'll wrap it up. I'm sorry for the last video in the semester to be one of the longest. It's probably apt that that's the case, but it's still a very long session to sit through, I recognize. All right, these are our new plots right here. Good. And then the last couple plots. Yay. All right, let's open this in the browser. Let's scroll down to the class 29. Okay, notice in the class 29 I've got all those subsections appearing in the table of contents where based on the rubric. I think that makes it really easy for the grader. That's why I encourage that. So I just click on logistic regression. I'm not worrying too much about the extra headings here. I don't think that's very important. So plot the data, we're going to see that below. We've summarized the p-values and the empirical logits in that code. and we show the first 10 rows of that table. There's the column with the empirical logits, so that's looking good. We create the plot first on the probability proportion scale. Code is there and the plot is here, and let me zoom out just a little bit. Oh, I pressed it only once and zoomed way out. In fact, I think zooming out a little bit will make scanning through this a little bit easier. Okay, so make sure that the dimensions of your plot sort of work out. 6 inches tall by 8 inches wide, that seems to work pretty well for these plots. Okay, so that looks pretty good. On the logit scale, all this text is stuff that was copied from the previous assignment. The grader's not going to worry too much about that. Oh, the size of this plot's a bit smaller. That's interesting. So if I come back over to the R code, let me show you where you can make those changes of the plot size. So I'm going to the first plot. There I've got a height of 6 inches and a width of 8 inches. I'm going to copy that line, because if there's another plot like this, here's the second plot where I didn't like the plot size. This has no code options, so it's using the default settings for the size of the plot. So I'm just going to replace that start of the code chunk with the piece that has the plot sizes on there. You might as well have all your plots be the same size. We're plotting the same data, but in just slightly different ways. So wherever there's a plot, I'm going to make sure that the chunk of R code, here's the next one, has those figure height and width on it. And this last one had it also. So I think that's better. We can click knit while we're scanning through the rest of it. All right, describe the plot. Is it linear? So there's my comment there that yes, the log2 improved the fit, and the straight line relationship seems to fit the data well from 0 up to about 10, but then it sort of falls off. So I fit the model, right? So fit the GLM model and assess the deviance lack of fit test. So here I fit the model, and I haven't shown the result yet, but that's because I'm going directly into the deviance lack of fit test. All this code is, or all this text is from the previous assignment, which is just helpful text for you. There's the deviance statistic with its degree of freedom. We have a small p-value, and ultimately, because the p-value is less than 0.05, we reject the null that the model fits the data in favor of the alternative that the model does not fit, concluding the model does not fit the data. However, this is, however, we're going to continue with the assignment. I'm sort of curious. I'm not going to do it, but if you were curious, you could take our markdown file and restrict the data to, the people who smoke up to 1,000 cigarettes, and see if the model fits for that. Okay, next. Calculate the confidence bands and plot the data on the logit and the p-scales. So this piece of code just should work for everyone as long as you've got your correct GLM model object in here. And then we print it on the logit scale, and this plot size will have been corrected. This regression line here looks quite good. And on the proportion scale, we get the curved version, and generally looks pretty good except for this right tail. And for yours, make sure you go through and check all the labels. Interpret the sign and test whether the slope is different from 0. So we print out the summary. We've got interpret the plus or minus sign. So because our slope is positive, as the x variable increases, the probability of success also increases. And then the hypothesis test, I'll put one piece of text in here. If I'd go to the very bottom, I'll just say hypothesis test, and maybe I'll put double underscores, which make the text bold. So then for the hypothesis test, I've got equals 0 versus not equals 0. The p-value is less than 0.05. See the scientific notation there? Because I wrapped that p-value with the dollar signs right here. So this part in the left tick marks creates the p-value. And then when I surround it with the dollar signs, in fact, I should put the second dollar sign on the over here after the less than equals, less than 0.05, because that's the whole equation. It typeset it in scientific notation. That's really nice. So because the p-value is very small, we reject the null in favor of the alternative. The alternative is that it's not equal, concluding the slope is different from 0. Perfect. 100%. All right, let's double check that we were just running the markdown. It finished. If I reset by pressing F5, if I refresh this page, we should have plots that are big all the way through now. So there's the first one, there's the second one. So I've fixed the size of the plots. So this assignment is done. Thank you for sticking with me all the way to the end of this long video. I hope that all the details that I showed in my assignment helped you very much to be successful in your own assignment.